Yeah, thank you. My name is Arvid Lilletun. I'm from the Norwegian Mapping Authority, and I'm going to have a presentation of some practices and tools that we use in the Norwegian spatial data infrastructure. And we think some of them are good to see, and they are working. So this nice picture, several of us are from this region, and we have use of data in also here. It's aquaculture, it's oil industry, it's forestry, it's agriculture, different things, and they need data, and also tourism, of course. It's a nice area. What we do when we work in the infrastructure, we are focused on users, and we are looking for user needs. And for instance, here on crisis management, we see what are the primary data they need. And they need both reference data and thematic maps, and they need not all kinds of themes from Inspire, but they need some of them. And these are national data, and they are of many kinds. For instance, here for crisis management, it's also, they need land use maps, risk maps, and exposed objects, and rescue resources. So we look for those data from the different data owners and see what can we get. So in our infrastructure, we have a focus on different kind of users, and 95% of the use is at the national level. So there are lots of users, and we have to care for them. But we are not isolated. We have an international community, both as users and producers, but also software vendors that are international. So we have to be adjusted to the and tackle international affairs. I have 9 examples here. The first one, easy to understand metadata, linking data sets and its deliverables. That's a debate and going on also in Inspire now, and we have a solution in the GeoPortal. It makes it easier understandable. What are the possibilities of how to access data? So we have metadata in the portal. We have then different kind of distributions. So we have the file distributions, we have the view services, or called display services here, and we have the download services. And if you see, we have different kind of download services for this data set, and we have them both through the GeoPortal, but also we have metadata for other distributions that are distributed direct from the different organizations. So here you can get a very good overview as a user. And one of these is a WFS on fish spawning grounds, and here you can see at the bottom, you also see the data sets the service operates on. So this is a very important linking between data sets and services back and forth. Next, easy to use map viewer gives users a good overview of available layers. And just a few examples here. For instance, on flood susceptibility zones, here is an area that can be wet in some cases, and it's important. What we see here is that the data are very accurate, and rough maps of flood zones is not possible to use, so they have to be very good. Here is another example on satellite images, and here is one on cultural heritage. For instance, on these cultural heritage sites, we have 500,000 of them, of course it's accurate information, and that's what the users need. They don't need the rough versions. What we see when now we are distributing lots of information, and the users start using them in advanced ways, and what we see is that they complain because the data quality is not as good as they had wanted. So we have distributed lots of data, but now they complain. So we need better data. We need better data for the land areas and for the sea areas. And we also need better full coverage. So this is something partly being a part of the infrastructure and partly outside, like the distribution part of the infrastructure. But data capture and investment in data is part of the infrastructure. Next issue, National Metadata Editor. It's widely used. It's improving metadata quality, and users get better information. So it looks like this. It's different kind of issues. It's easy to use, easy to understand, and easy to fill in. Another thing we have done to boost the use is to have metadata in a mainstream, into mainstream search engines, and there we have used indexes, Solr indexes, for easy access of metadata. And here you can then, like in Google, get good information on, and this is something also being discussed now by JRC in a slightly different manner. And here you can get information on like both datasets and services. Automated description tools. Here we have subscription tools, and this is one of the very important things we have made. It's we see that WFS services are not so good to use. Many need data in other formats, and we have a kind of bulk download the subscription tools where they look at a user can get data from different kind of services through the Geo portal, and they look at the date stamp, and here they only get new data that has come for instance, the last day. So they get fresh data for breakfast. Centralized system for data harmonization and distribution. We have seen that many have troubles in making harmonized data, so therefore we have a national portal through that one. We also have centralized some production, and we are using FME, and also Jenkins here for workflow management. And some of these processes for processing a data set takes 17 seconds, for another it takes 10 minutes or much longer. So this has resulted in a lot of new WFS services, so we have a good, it's expanding very fast now. Cartography, in order to get good use, we serve cartography as SLD, and now in half an hour, my colleague will have a presentation in, I think it is a Gorilla 3 about cartography. So the ones that are specifically interested in that could go there. It's symbols and it's SLD cartographies. Follow-up tools. We are following up the organizations that are delivering information. We are simplifying the Inspire specifications, directive with 400 pages and regulations, guidelines for 4,000 pages, but we have selected 10 important issues that we focus on. Yeah. So this is very handy tools, and they are working, they understand the requirements, and we can see if their progress. The national validation tool, that's something it's being built partly on Inspire, or mostly on Inspire API for validation. we have it. It looks like this, and it also simplifies the communication towards the data delivery organizations. And here we have an integration between our own system and also into the Inspire validator. Yeah, if you want more information about these tools, they are available on, many of them are open source and available on GitHub. You can have a look at the GeoNorway to get a view. We also have Kjersti here. She is going to talk about priority data strategy tomorrow at Gorilla 1. So please go to one of these if you like to hear more. Make a try on GeoNorway. Come and discuss with us afterwards on tools, on APIs, on different things. That would be very great. So thank you very much.
Thank you, Arvid. Maybe we still have some time for some questions from the audience. And I see already one question. Thank you for your presentation.
Mikko Hyninen from Finnish Environment Institute. We are also an Inspire organization and have lots of data sets and pretty much the same delivery types than you have. My question is that have you managed to automate the process of creating different download services from the same origin data, as you said that you have atom feeds and WFS and just files. So do you use the same source data and some common process to deliver all those data sets?
We, in this centralized system, there we have a connection to the source, the different organizations, and then we bring in through different kind of APIs, REST APIs, or a simple WFS, and then we convert it or harmonize the data. And then we put it into PostGIS database, and that's kind of harmonized source. And then we can make different kind of, we make export to with atom feed, and then we also use the same data as a source for the WFS services. For the WMS, we make a kind of copy because we have to structure it a slightly different manner. So the WMS is not directly from the databases. Maybe Lars Inge can explain some more.
We are using FME to produce the GML files, and we are also making the atom feed from over these files with FME, and we are using Degree for producing the web feature services.
It is automated. Yeah. Okay. Time for one more question. Maybe I also have a question. So you were talking about the users want more quality, better quality, right? But I usually teach my students quality depends on the purpose, so the fit for purpose. Do you ask the users of your data what are they using the data for, and how do you ask that?
We have a very interesting project now. It's on building permits, and they use quite a lot of different spatial data, and we have a detailed assessment of user needs, and we talk with the different kind of communities, and we identify very many kinds of problems. Or one of them is on data quality. The other one is to extract what is the information and of each of the different data, because it's drowning in different kind of information, and you need to extract what is really what's needed. So we have a good discussion towards some of the main users in the public sector, particularly.
Yes, user surveys. The microphone.
Thank you.
Janet, the floor is yours.
Hello. Nice to see so a big audience even in the afternoon. I'm Jeanette Storm from the Netherlands, working at the Kadaster and responsible for the addresses and buildings register. This will also be in the presentation. Contrary to the previous presentation, which was a lot of tools, I will talk about one type of tool, but we use it for several registers. And I hope you get inspired by how we do that. So I will tell a bit about our system of key registers and the role that we have as Kadaster, and of course about our quality dashboards. Our system of key registers, it contains, for example, the person's records, the Chamber of Commerce, and several geospatial registers, like the addresses and buildings, large-scale topography, mass valuation, and the parcels register, the Kadaster. And these registers all contain just key data, and the idea is that we don't mix them up in different registers, but we use the data, like for example the addresses. They are registered and uniquely identified in the addresses register and used in, for example, the Kadaster and the person's records database. So there's a lot of links, administrative and geospatial, between all those registers. And that makes it easier for, well, the Netherlands and the companies and the government to do things in an effective and good way. So the addresses and buildings, this is a screen print from our viewer, online viewer with the addresses and buildings. It's called Bach viewer, because Bach is the way we call this database. It contains both addresses and buildings, and they are always linked together. If there's no building, there is no address. So that's one of the reasons, a way to get it complete and uniquely identified, and makes that we have in the Netherlands a very good linking pin between the administrative data registers and the geospatial registers. It's there since 2011, with all the municipalities updating their data on a daily basis since then. Then we have the topography. It's maintained by the Kadaster in several scales, and they are automatically generated from one scale to another. Continuously updated with 5 releases in a year. So per year we try to update the whole country. Then large-scale topography. It's a key register since a couple of years, and since last year it's completely filled for the whole country. That's all the municipalities, but also some bigger areas like provinces and what's it called? Infrastructural properties. And this is one of the, let's say, key registers that is still in a kind of initial phase and needs a lot of quality updates, because that's what we're talking about, the quality dashboard and its function. So I will explain that a bit more. For all these registers, the Kadaster has a role, but we are not all responsible for the data. That is for the topography, we do all the activities, but for the addresses and buildings and the large-scale topography, it's the municipalities that have the main role to update the data and to keep it up to date. But we try to help to get that updating in a good way and in an efficient way. And also, regarding your question for the previous presentation, to listen to the users and try to update the quality of the things that users think are most important to make it usable data. Quality management is what we call the way we act on these data sets as a role for the kadaster. For the addresses and buildings, it used to be a law with a quality system that was really looking back at what did you do 3 years ago. And in our council with the users and also the municipalities, we said, well, this is not working. We're not going to get progress in the quality of data if we're only looking back how the processes were in the last couple of years. We have to look at the data now and fix the problems that we see and that we find every day. And so we started to measure things that we could measure in the database. And afterwards we started combining data and like our postal codes are still maintained by now a commercial party. But they have to be correct in our addresses database, because without the correct postal codes, an address is, well, kind of useless. So it's not a responsibility for a municipality to give out the postal codes, but it's the responsibility for them to keep it good and quality good. So they have to, that was the first thing to address and make sure that it got better. So I show you the way we present that in a quality dashboard. So we started with Excel files and other things that we shared, well, first once a year, then every 3 months, and now we update this every month. And this shows per municipality. They log on to a system where they can access this data. They log on and they see, well, I'm doing well or not. There's light blue for the average for the country and dark blue for their own situation. So if you're, for example, in this case, it's only dark blue. That means that the national average is below 95%, which is, of course, 95 is a high. It's all above 95%. So it's a very positive result, but still work to be done. Let me see. So this gives you an overview of how you're doing for the several themes. And the themes contain reports that we've decided upon together with the users. So when I click open one of these themes, there's several reports, and they show how many mistakes there are. And we know that they are mistakes because we combine information within the database, and it says, well, either this is really wrong, for example, a building year and a construction date that do not match. There's too many years in between. For example, as I said, we have a building, and in this building there's objects with addresses. If the address is still existing and the building is not valid anymore, then it shows up here because it has to be in line with each other. Also, we try to focus only on the things that are really wrong, or a big chance that there's a chance to improve. Because if you give this municipality every month a list with thousands of problems, well, then maybe they will solve some things, but you don't see which to start with, and if you find some that are quite okay, then you're not so, there's no urgency to do the rest. So we focus on the real problems so that they get better and are improved every day. Any idea why we do blue colors? Yeah, we look at it at the positive side. And so we're not telling all the time this and this and this and this is wrong. Yeah, okay, the exact figures, but not in the overview. Because it also shows that it is quite well, but it needs improvement. And it doesn't help to see blinking red or whatever every month and then hoping to get better and it's still red. So it's a neutral color on purpose.
Does it also have a naming and shaming effect? Can anybody look at the figures of any municipality, for instance?
Yeah, we have a separate site for that. This is when you're logged in and you can go into the details and you can make remarks. That's only open for the municipalities. But we also have an overview on the public website that gives you the same results but presented in more in a geographical way. So you see the map of Holland and then you can zoom in. But you can also see and you can download the whole set of potential faults. And that helps, for example, the tax institutes. Okay, they know there's something wrong with this address, so I don't have to use this. Or it gives an indication that there's something wrong. So for the municipality, they dig in deeper. So clicking on one of the rows will open this view. Well, of course, this is wrong. But if you see it like this, then you notice, oh, okay, this is the list that I have to work on. And clicking on this ID will get you into the online viewer, and you will see directly what object it's about. So that's easy access and easy overview of what to improve. And in the end, also an overview for the users, what is going better and what's okay already. So I think I have to finalize. And then hopefully you will ask me a question with more details and then we can go into the online application. This is a sheet of the online So this was the overview.
Thank you, Janet. So, is there any question from the audience about additional details on the dashboard then?
They are very happy with it. They are also asking, okay, now you have it for the addresses and buildings and for the topography. Please make it also for mass valuation and all the others, because it's very handy and they know they get complaints if it's not okay. So they know where to go to improve the data.
So does that mean that they don't know themselves that they have errors in their data? That you show that they have errors, but that they don't know themselves about?
They do know that they have some problems. But and there's also municipalities that have their own queries and stuff, but and that may also overlap. But the handy thing is that we have the whole database, so we can also compare one municipality to the other. And if we do it, why should they do it as well? And this pinpoints exactly where to improve. And that's also a reason why we you saw that we use blue, but we use light blue and dark blue. And the dark blues are only there if there's new problems. Because we want to focus them on new problems that occur. Because that may be an effect of a change in progress or processes or in people missing. And so that's focus on the new problems so so they don't grow.
Yeah. Yeah. Okay. One more question. Yep.
Did you saw any improvement after you introducing the dashboard?
Yeah. When did you introduce the dashboard, and has there been improvement? Oh, I see it. Yeah.
Yeah, we have seen improvement already when we didn't have the dashboard, but since we introduced the dashboard for the addresses and buildings in the first a little less than 2 years, we saw a major improvement on many of the aspects. Yeah. So yes.
Yes, good question and a good answer also. So I'm going to close the discussion now. So in my mind was, this is so obviously useful. Why don't we use it more? And why is it not available in more places? So if some of you are considering also this for your own data sets, please come and visit Jeanette. And she'll be here. And then have a look at the dashboard, how it works in practice, because it's online. She can show it to you. Okay, thank you. Thank you again, Jeanette. Yeah.
Thank you. Hello, so I'm Philippe Duchesne. I'm working on several projects related to geo-linked open data. And I will be talking today about a specific project named Data Mosaics that involves annotations and geodata. What's the context first? So that project Data Mosaics originally isn't about geospatial data or inspired data at all. So the few first slides are going to set up the context, and it's not going to be geo-related, but I'll get to the point. So the context is we have a whole set of open data out there, and we want to be able to annotate it and mash up the data to create reports, to create whatever things we want to create by aggregating different data sets. And so we have a user, multiple data sets out there online. And usually the problem is that, so we want to collate hypermedia resources, but the people who want to do that, they have problems such as, well, the data is not theirs. So they have data out there, but it's not physically theirs. So they only have URIs, URLs. So they need to organize the data to create what's called a data mosaic, so which is a document that mashes up the data. They want to annotate that data, and they want to store the result of all those annotations. They want to store it to be able to exchange it, to share it with someone else, still not owning the original data, but they want to share the results of their annotations of these data sets. So this sets of annotations, this mosaic, becomes a resource of its own. It's a document by itself. So to implement that, we have been using a fairly recent specification, which is the web annotations of the W3C. I have put a picture of the object model here, but I won't go much into the details of that here. But basically, it's a specification, it's a standard to express the fact that you annotate a certain URL with another one, and you can possibly add semantic annotations on that, and a lot of other typical Dublin core metadata, for instance. We'll get into the details of that. So one more thing. So I've been explaining all this, but usually what user wants to do, it's not just annotating a whole data set, like, I don't know, like a PDF or a video. They want to be able to annotate a fragment of it. Just take a piece of it and annotate 1 minute of a video and link it to a certain paragraph of a PDF, for instance. So that W3C specification deals with that and expresses the notion of fragments. Again, I'm not going to go into the details, but I will give you examples. But first, then we get to geodata. So I'm talking about fragments. There are already in the various specifications online for instance, specifications for CSV, for HTML and so on, there are the notion of URL fragments is standardized in all these specifications. For instance, you have a standard to express a certain page number and a subset of the screen for a PDF. What about geospatial? Well, there's no standard way to express URL fragments for geospatial. So we came up with tentative expressions to put that in URLs when addressing geodata data sets online. Like, obviously, the bbox fragment. For vector data, we have an expression that's able to say, okay, I want, typically for WFS, for instance, you want to be able to say, I want this feature type and that feature ID within the WFS. You can also imagine having a temporal fragment, which exists already for other data types, like a video. You want to be able to target a certain temporal fragment. Well, for instance, KML or temporal WMS, they have a temporal dimension, so you may want to address to target specific temporal subset of these data sets. We have a specific problem with or issue with the geo services. That's expressing fragments for services and not strictly data set by themselves. As you know, when you address a WFS, you do a get feature, you give the type name and so on. But in the system that's been designed for these data mosaics, you only take the base URL and then you express the fragment, because one important notion to understand is that the whole notion of fragment is processed on the client side, not the server side. When you have a URL like the one on top, it's opaque for the client, for the browser. You shouldn't be able to know about the fact that it's a get feature. You just take the URL, you resolve it, and you may get GML. But what we want to do with data mosaics is that we want to be able to say, okay, I have a WFS there, and you have to know about the fact that it's a WFS, and I want on the browser side to say, okay, I want to take this feature type, that feature ID, or that bbox in the WMS, and I want to process it on the browser side. Yeah, I'll skip that, but this changes a bit with the new specifications such as the WFS3, but I don't have the time to go into the details. Keep that as a question for later if you want. Going to an example, here is an example of what this actually looks like. That's an annotation. Here, for instance, what we say is that at the bottom, at the top, we have, for instance, a WFS, and we say, okay, I have a specific feature in that WFS, specific feature from a specific feature type, and I want to annotate it with 2 rows from a given CSV file. And this becomes an annotation that is a document on its own. You can exchange it with someone. It will be valid for someone else. You don't own the original data. You just exchange this. I'll skip that because I don't have the time. Now, a bit more about the notion of linked data. So I've explained what those annotations are. Now imagine that you have a lot of data sets out there, and people are annotating them. So you will get annotations like that between all the data sets. For one given domain, for instance. For another domain, you may have other people annotating these same data sets with other links, with other semantic annotations. So, yeah, semantic annotations, for instance, assuming you have a specific ontology for your domain. And so all these links are decoupled from the original data sets and become a set of metadata on their own. And all these links can become a document, and for each domain, for each use case, you can have a different document. And this set of documents, this whole set of annotations, becomes an added source of metadata, and it can be metadata per domain. On top, it augments the original data, if I may say so. So the outcome, well, as I said, it's that you have monolithic data to start from, and using these annotations, you can split these monolithic data sets and turn them into linked data fragments. And so the sum of all these annotations becomes a queryable graph that is a source of augmented metadata that gives context to the original data. Yeah, and in an open data context, like for instance, governmental open data portals, you can imagine that all these annotations may be crowdsourced. People are just annotating data as they discover data on the portal. And the sum of all these annotations can be seen as a crowdsourced metadata source. So I think I have 1 more minute, so I'll go. I like living on the edge, so I'll try demo. 2 minutes, even better. Will this work? Or maybe I have to escape. How do I, hold on, sorry. I should probably escape this first. Yeah, and then go there. And then, where is it? I'm wasting my 2 minutes. I'll do it manually. So I have prepared a demo here. There we are. So that's a demo deployment of the tool I was talking about. So I have just a few, so the resources you see. So I have selected this Inspire 2018 demo. That's a mosaic, and it contains several resources that are annotated. So I'll take a first example. That's this use case. So the goal here is to show what it's possible to do with such a tool, and also some use cases at the same time. So here I'm taking a PDF. It's an administrative report on some floodings that happened in Belgium a few years ago. So it's been annotated here. We can see the annotations. It's annotated with some video, for instance. But here, for instance, if I go there, we have a paragraph there. And it's actually taking a WMS from the Walloon region about flooding risks. So it highlights the report with some actual data from an online WMS. And for instance, you can see that the report is also augmented with some CSV data. And so you can see that the links, you really have fine-grained links between all the different data sets. And it would be interesting also to show you that what it really looks like is, oh, hold on. Oh, no, I don't have it, but I'll show it later. So that's one use case. Typically, decision making has been one of the root use cases. It's the end. Huh? Okay, I'll quickly go. I had some temporal WMS. I'll go to this one just if you allow me. That's an annotation of that's the new OGC WFS3 specification, and for instance, you can annotate technical report here, annotate the specification with an example of an actual WFS3 online. There you have. I have other examples, but I've reached the end, so just ask if you want. Yeah, of course. Let me get back to, yeah. Thank you. So there we are.
So it's also nice that you can, now you've seen Philippe in action, that you can actually explore, and I think it's open, right? There was no login necessary. So
yeah,
you can go and explore a bit.
You can use it anonymously.
We have one question from the audience.
Yeah, you said you had the problem with the ordinary databases and WFS. It was monolithic, and you wanted to move to something, going into the data, into the features, and so with this, and you have the REST services there, but you said something at the end now with the WFS 3.0. Yeah. Could you say a little bit more about what will happen and when is it coming? Just try.
Don't ask me about when WFS3 is coming. Go to Clemens, who is somewhere out there. He knows. I don't. But in the scope of this tool, we have been adding support for the new WFS3. So what's interesting in this context is that, well, when I talked about monolithic data sets, that's especially true, for instance, for WMS, where you have basically raster, and so you may want to be able to pinpoint a certain geometry in there. Of course, a WFS is already less monolithic because you can target directly a certain feature type. But from an API, from an HTTP API point of view, definitely a REST-based implementation is much more suitable for directly targeting a certain feature, because features are directly accessible by URL, which is not the case for a traditional WFS. So you may imagine that the syntax I just presented, where you have a URL of a WFS and then a URL fragment, you can imagine that for WFS3, you would no longer need the fragment itself. You can have directly the URL pointing at a certain feature within the WFS, and it will still make sense. And what's important to keep in mind is that you want to see, for instance, a feature or a piece of data as part as a whole. If you take, you can take a WFS, a traditional WFS, and directly express a get feature request, and it gives you GML. But then from the browser, from the client side, you no longer have the notion of the whole WFS. You just have a piece of GML. You see what I mean? You don't know, because the URL is opaque. You don't know it's part of a WFS. If you have a URL targeting a WFS3, targeting a feature of a WFS3, if you respect the specification, as part of the response, you will have headers that tell you, okay, this is a single feature, but it's actually part of a certain feature type within a certain feature server. So you still get at the client side the notion of the whole data set and where it comes from.
That's a good answer, good question also. Another question from the audience? Yep. I have a question, that's why I wanted to have time for it. So, I really like the example of annotating a document, and then you can then link the document to this thing. So, and the idea that you said crowdsourcing information. Can you give us yet another example of where this could be interesting, that we will then link, the annotation will be going directly to features? Who do you think are the users for these, and what kind of examples can you think of?
I don't know about specifically vector features, but the general examples I have in mind typically as use cases are, I talked about decision support, definitely. Open science. When you publish a scientific report, it would be nice to have annotations that point to the actual data sets online. Data journalism. Yeah. If we could have, when you read a newspaper online, if you could have a version, and what's also important to understand is that it's totally decoupled from the actual data. So you can have all I have just said, science report or newspapers or whatever, they exist on their own, but someone on the side decides that to publish annotated versions of these.
Yeah, so sort of an open transparency, democratic data set. Yeah. Okay, thank you, Philippe. Thank you so much. Again.
Okay, thank you. Okay, good evening, ladies and gentlemen. We're going to speak a little bit about a very simple experience of transforming expired compliant data into linked data. Well, okay, let's start with a quotation by Charles Baudelaire, who said in a very famous sonnet titled Correspondences that all scents and sounds and colors meet as one. It seems that he was speaking about linked data, isn't it? It's in 1957. Well, first of all, we will explain the justification and purpose of the work, a short background on the state of the art. We will describe the methodology applied, the results, and some conclusions. Okay. Sorry. Okay, what happened here? Okay, sorry. As you know, linked data is an ongoing trend in the geospatial community. There are two ISO documents, a technical specification about ontologies, stay in the framework, and ISO 19150, part 2, defining rules for developing ontologies in ontology web language. And also, there has been an arena activity for expired linked data. Linked data allows to have data interoperable with very heterogeneous data sources and different knowledge domain. The transformation of spatial themes is an easy way to begin to do some activity in this world of linked data. It's necessary, first of all, to assess the technology requirements and then to develop a methodological approach to transform inspired compliant data into linked data. We have RDF as a main point of interest, Resource Description Framework, which is a language defined by the World Wide Web Consortium, a very well-established standard. It's a very used standard for semantic web and linked data, and has the capability of sharing vocabularies between different knowledge domains. Also, we have GeoSpark-QL, a language for geospatial queries in RDF datasets, developed by OGC. Some data stores for RDF triples are implementing this language. The methodology, well, first of all, it's necessary to define between inspired themes XML namespace and RDF ontology, using ontology from Arena activity. Is implemented in RML language. RML is RDF mapping language. It's a standard to define mappings between RDF datasets. And we have applied the methodology to administrative units and geographical names, the more simplest themes in Inspire. We have developed a software process to execute RML mapping over web feature service datasets from the Geographic Information National Center. We have used datasets obtained applying web feature service in order to generate RDF triples and publish these triples through a SparkQL endpoint. We have used Parliament as data store because it supports GeoSparkQL natively. Virtuoso also could be a good choice, but it doesn't support GeoSparkQL natively. And we have made some experience querying another service from DBpedia in order for link inspired data to external attributes. I'll make a sample example. Here you can see a view of the results. I don't know if it's possible to say that here in RDF translation, we have the administrative units linked to the upper administrative unit and the lower administrative unit too. Here you can see a query example. I'm looking for cities contained between the geometry of the province of Seville, which is the third level administrative unit is in Andalusia. And they're looking for these cities with their corresponding location and population, which are into the geometry of Seville, extracting the attributes, location and population from DBpedia endpoint. And well, you can try to read all the query. It's not too difficult to identify all the terms of the query. And you can see the result with a list of cities with population and coordinates. So it's not so easy to begin to do things with linked data. And our conclusion is that we have a prototype pipeline for linked data publishing that can lead to a production environment. We have geographical names and administrative units, WFS, from Geographic Information National Center completely translated into linked data without any problem. And we have a SparkQL endpoint successfully connected to external service with a simple example. This endpoint is now working in the intranet, and now we're trying to solve some technical problems to publish in the web to offer to the resource to the linked data community. And well, that's all. Next steps of the project during the rest of the year and next year are going to be extend the process to the rest of inspired themes, First of all, for transport network, then to ideography, to improve the endpoint performance, to make links with Wikipedia and geonames, to also try to establish links between other inspired teams, for example, between hydrography and geographical names, administrative units and transport network, and create a more usable interface. And well, that's all. Thanks a lot for your attention.
Thank you, very much on time. Yeah, very interesting that you're experimenting with linked data, and now what will be the added value. So maybe some questions from the audience. Already a question here. If you don't have questions, also maybe some comments. Have you experienced with linked data yourself?
How are you doing the... Oh, sorry, I'm Jake McGregor from Minerva Intelligence, and I'm wondering if you could elaborate on the process of going from WFS to RDF.
Excuse me, I haven't heard the question.
Sorry. Could you elaborate on the process or how you are doing the transformation from WFS to RDF?
Well, I have forgotten to explain that this little example has taken the work of 3 people devoting more or less the 60% of their work time during 4 months. Globally, something like 7 person months. Did you ask about the process of linking the object to the object of the Wikipedia?
No, the WFS to the RDF. So you showed that there was an arrow. So this is the WFS request, and then this will be the equivalent RDF. And,
yes. Okay. Okay. It has been necessary to define a mapping in air mapping language, then to execute the process, and we have had to solve some problems interactively because it's not possible to automatize completely. And this is a very simple theme. So the model of the theme is quite simple, but it's not necessary to solve. It's not possible to solve all the transformation automatically. Okay.
So you made a manual translation.
Yeah. Some problems. Okay.
Yeah. Next question.
Yes, Marcin Grudzień from Head Office of Geodesy and Cartography, Polish NMCA. I have a question whether you created ontologies for Inspire linked open data, and if yes, whether they are available online.
Well, yes, all this data is published as open data, of course. Yeah. And we're waiting to publish on the web and to make some outreach to offer the resource to open data and linked data community to use it and prove it and test it. And
yeah,
so on.
But do you know if you created ontologies? So you create like for Inspire teams, what are the semantic, the names that they mean, a kind of an ontology for the data
okay.
sets. Did you make that?
Yeah, no, I don't know. No.
It's okay.
No,
but
sorry.
because I think that would be one of the holy grail that everybody is looking for, if we will have a common language, a common ontology within Inspire.
Okay.
Yeah.
I speak English just a little. But
yeah.
I think there is a correspondence between the
already made
UML model and the ontology. Like a correspondence. There is a document to mapping. I don't know.
Yeah.
I speak English just a little, but there is a mapping, a document.
Yeah. My feeling also, yeah.
To map from UML model to an ontology.
To the Inspire ontology.
In Inspire.
For Inspire, yeah. My feeling that this has also been made. You know more about this work also?
Yes. There are a document titled Guidelines for IDRF Codification of Spatial Data, I think. Something like that. Okay.
So Peter Paslow from Ordnance Survey. I had something I was going to say, but I will make a point on that part. My understanding is that the Inspire specific semantics, the bits you might want as an ontology, are available in the Inspire registry, which will give you back a SCOS or OWL representation if you ask it right. That what's not so easily available is the underlying ISO TC211 semantics. Paul did a presentation about that earlier, so I suspect that in the Netherlands that's kind of in hand.
But the thing I was actually going to say, if I'm allowed to, was from Ordnance Survey, we did a similar exercise with our geographic names a couple of years ago, but we took a very different approach. So and from that, we've got a lesson that I'd like to ask you about. That, so what we did was to make all those outward pointing links to geo names mostly, in our case, by actually manually doing that. So we were sure we were linking to the right thing in geonames. We didn't trust the automatic things we tried. So we actually maintain that within our internal data set, saying that Southampton is the same as that Southampton over there. And we publish that actually in our GML, from which by a Python script we then derive our RDF. But what I think we should have done is to publish all those links as a separate link set. So we'd have the Inspire data set and then a separate link set that says this is the same as that, or this is inside that, and all those things. So have you, I suppose because you're just publishing it in linked data rather than embedding the links in the GML, that's actually a separate thing, because every link is a completely separate sort of instance atomic item in the linked data world. But did you face any problems or with it getting the matches to DBpedia or to geonames and actually getting the right results out of a Sparkle query? Did you have to manually correct them afterwards? Or no?
So the question is about the experience of our colleague for Ordnance Survey. They actually make the links, the link data, manually. So make sure that the geoname Southampton was the same as in their database. Did you do that also automatically, or did you encounter challenges in the links between DBpedia and your own spatial data?
The linkage with DBpedia data was automated in some percentage. It's quite difficult to evaluate, but it's not completely automatic, no.
It was, you did it, yeah, but then you have to manually correct it.
Yeah, in some part.
All right, hello everyone. I'm Jeroen Hogeboom and I work for PDOK, also for the Kadaster. And I'm gonna tell you a little bit about the location server that we made in cooperation with other governments of the Netherlands and also the police department. I will tell a little bit more about that later. But when PDOK started, we were like a public, open platform, and we supply a lot of data. Previous Jeanette gave a presentation about the addresses in the buildings in the Netherlands and about the topographical data. All that data we supply via one central platform in the Netherlands, and we do that together with other governments. So we are also a government party. So it's just not one party doing it, but many of them. So we can share costs, and we don't have to invent a lot of things like separately. So what we supply is a lot of data, but a lot of people want to make a viewer, or they want to make a website. And when they make a website, we can all, I think, imagine Google. If you go to Google, what do you want? You want to see a background map, you want to see aerial photos, but you also want to be able to search. And that's what my presentation is about today. The ability to search data. So instead of showing it on a map, instead of using WFS, yeah, but it's a bit complicated for some people not in the geo work field. So we made an API, and that's what I'm going to talk a little about later. So go to this. I'm going to show a few data sets that we use where you can search for. This all started, I have to mention, this all started by the police. So at the police station, at the police department in the Netherlands, if an accident happens or whatever happens, they want to search for a specific object, like a building or like an address, a cadastral parcel, a location, whatever they want to look at. That's why they called it the location server. They invest a lot of time, and it was a big project, and they invested a location server of many different Inspire theme data sets. Because we had a geocoder, but we made our geocoder ourselves. I think a lot of organizations make their own geocoders, and everybody makes it a bit differently. Our geocoder was a bit, not that good. The police made a really good one, so we had to talk to them, and we shared code, which I think is really good. So we don't invest a lot of money again. After talking to the police, we also were able to use the developer of that used to work for the police, and we started with Searching for addresses, very simple. You want to search for your street, so you have a map. You have an Inspire map with all the cadastral parcels. You have the streets on the map, but you want to search for it. The good thing about the addresses, it's Jeanette gave a presentation before. It's daily updated, so we daily update our database. Daily, everything that changes, we hear it like the same night, and we update the data. So because of adding the data of the addresses to the API, you were able to find addresses. But then a lot of people said, yeah, that's very, very nice that we got addresses and we have streets, but that's not all the streets in the Netherlands. That's only certain streets, but that's not like the main roads, like the highways, but that's also not a lot of roads because in the register, the address register, we only have like certain kind of roads. But the two data sets together, that's what's very interesting. If you combine the two data sets together, you get pretty much all the streets, all the roads in the Netherlands that we know of right now. And that way you can say, well, it's actually more accurate than Google, because if a municipality decides today to change something or to make something new, we know it the next day, and it's in the search API, which I'm going to show you later. We had a bit difficulties though, because if you want to combine two data sets, well, that's where Inspire standards come in as well. So we didn't use the Inspire harmonized standards, but for us what was very important, that the names of the roads were the same. Because if you want to normalize, if you want to put two data sets together, you need to have an identical identification. In this case, it was the street names. We did it, but we saw there was 30% that was not possible to put in the API. So for us that was too much, because if we're going to supply an API that everybody can use in a viewer, and a lot of streets are not findable, although the data is wrong, you have a problem. So we had a talk to the different organizations in the Netherlands, to the Bach and to Rijkswaterstaat, very Dutch words. Anyway, we had a talk to them, and we sat down together, and we gave our results, because we are, in this case, the suppliers of the data, but also the users of the data, because we want to combine the data. So for us, this was actually a really good example of what do you do with Inspire data, of what do you do in data in general in a country, and where do those organizations have to work together, and where do we get a good result, so people can simply put their API, which is free and open, in a viewer, and don't have to build all their own geocoder, but now you got an API, a geocoder with actual data. In the end, I think now we have less than 5% wrong roads, which I think out of a lot of roads in the Netherlands, I think that's not the biggest problem. So we talked to the Bach, and other people decided we're going to supply this data. Still now, we send a lot of information of using the data to the owner, and the owner is correcting the data. So what I'm trying to say, what's very important, that data is correct. It saves a lot of money. The quality of the data is very important for users. Also very important, because after that we added the cadastral parcels, because there's a lot of, well, I work for the cadastre, who's like maintaining PDOK. There's a lot of applications in the cadastre. They want to be able to search for cadastral parcels. So instead of every department making their own API, there's one open free API in the Netherlands, also for, well, my own organization. And they want to search for cadastral parcels. Again, while working in it, the quality is very important. So that's the third data set that we added to the API. Then a lot of people said, yes, but I live in a city, and I want to search for a specific district information or area where I'm living in. Well, we have a statistic department in the Netherlands who has the data. We also have administrative units, water. We have a party, and they have the data. They all supply the data to PDOK once a month, sometimes every day, some a month. All the data we connect together. So we connect them to the addresses. So if you search for an address, you get an JSON or an XML back, also with the information, and you can search for it. Another thing that's very important is also actuality. I think in Inspire that's a little bit, I don't feel that it's mentioned a lot, but it's very important if you want to combine data, that you make agreements on actuality or the punctuality of the data as well. So that's for us still a little bit hard. See, I only have a few minutes left. I'll go to it a little bit quicker. So we made a suggest service, because if you want to search in Google and you type in the first 4 letters of a street, you want to have suggestions, right? But also, you want the suggestion to start with, for example, if you do HOO, you want the first results to be first streets, then postal codes, or then cadastral parcels. So we made the API for people to be able to choose their own priority of the suggest service. Then you have a lookup service. I won't go into the technical details, but that actually gives you the object back, and the object with all the object information, and the most important, the geometry. That's what leading you to the place in the map. So I want to show that a little bit. So just before, Jeanette was giving a presentation. I see this is a different keyboard. There's a cue. For example, do it like this. Here, this is the Bach viewer. The funny thing about this is, the Bach delivers data, Inspire data to PDOK. PDOK supplies the data via the API, and at that search query, here you can say, for example, if you want to look for streets, and it gives results back. And this goes into the address register, but you can also look for cadastral parcels, you can look for many things. And here you can search for location again, but here you can also say, well, for example, the European highways, so you can search for the A1, you can search for cities, you can search for postal codes, you can search for cadastral parcels, etc. So we made this API open, but every year boundaries are changing, for example. So every 1st of January we get the new boundaries of the Netherlands. But for example, the area's boundaries, the area information, we get it in May. And the key register of addresses and building, they change the data on the 1st of January, for example. So we have some problems with combining all the data if the data is from different actualities. So that's yeah, something I find a little bit also Inspire a little bit hard. Okay, so we supply all this data, but different countries, or even in our own country, we supply data sometimes daily, sometimes monthly, sometimes yearly. But if you want to combine the data and do something with the data, it's very important that, yeah, that it has the same actuality. Anyway, yeah.
Thank you. Thank you. Yeah, also interesting story that instead of you helping the police was helping you. It's also a very interesting story how this came about. Questions from the audience?
I think everybody wants to go drink beer or wine.
Or if no questions, maybe some reflections on, oh, I also tried geolocator, but a different experience.
No, it's more on the use. It looks as you use it yourself, but other users, how do they like this kind of open API, and how do they use it?
Yeah, very much. So in the government world, okay, just in the cadastre already, we have certain viewers and they're all like implemented in that viewer, but also QGIS. QGIS implemented the location server into QGIS. So if you download QGIS, Netherlands, you get the location server. Also, we have suppliers, like, for example, the Netherlands Net Graphics, so just an example. They supply software, and they implemented this geocoder in their software. So it's not only the government itself, but it's also the private parties who can use this geocoder, this location server, and don't have to invest in making one themselves. Plus, in the end, it's all about the quality of the data. So at the moment, very much usage, but it also helps the quality of the data to become better. Yeah.
Yeah, interesting. And is it free and open?
It's free, open, and yeah, free and open. Yeah.
One more on value adding, or different companies. It's open, so different companies can use it, and they can use it into their softwares. Do you see that others are also delivering on your service? They're just copying it, or maybe adding some advertisements or something. So then you have a kind of authoritative data, and then you have lots of different kind of search engines or search location searches that are just secondary or from other kind of companies, but they are using your own data. Do you see that?
Yes, they are. There are many parties that made their own geocoder. Sometimes it makes sense because they just want to use specific data, or they want to adjust the data and put it in their own geocoder. So they say, well, yeah, it's very nice that you use this specific data sets, but I actually want to use my own data sets. So it depends a little bit on your use cases, but for many use cases, for specifically search engines, this service is used. Yeah.
Interesting. And the question of adding value is also interesting because you invested in this, you expect added value for the society.
You do, yeah, exactly. Yeah.
Did you measure that already?
Yeah, so like I said, like Net Graphics is just a party. It's just an example, but they have they work for very much companies, and they use it. Because they can use it, they can make a better product, sell their product, more taxes is paid, open data is paid. So the concept, it's proof of the concept of open data for me, yeah.
Question?
Yeah, maybe one question.
Yeah.
I'm Ronald, I'm working before this Locationserver. But the question is, do you also have examples that it's not only a search, but also for using as a register? Like that you can add it really into a system.
Try to understand what your question is.
You can harvest it now. You can use it as a search, but then you can you also really can use it for exchange or for register your data. So you can combine it together. Is it also used?
I don't know examples of people using it that way yet.
Only for searching.
Yeah, it is like it's not a WFS. We always say to somebody, so it's not a WFS. So we try to keep it as much as a search engine into the data. If you want to really like specifically, you have to. I don't have examples of that. Yeah.
But it's open, so it's possible that somebody could harvest the data set.
Yeah, in the end they can harvest the data set, and then the data set is combined, so you can use the API for, there are examples for just specific people that send specific IDs, but it's still usually, it's the examples I know, it's still used in a viewer or in a specific case where they only limit the search or limit the objects, or you actually, like in the bug viewer, you're allowed to put an ID, so you send the ID and you get actually back the information. That way it's used, yeah.
I would be very curious if you do this measure of added value measurement. So really look into, okay, we as a public body invested in this service. Yeah. What is the added value back to society from companies, from this? I would be very interested if you then do this kind of work.
Me too, yeah, for sure.
Very interesting to keep in touch.
Yeah.